2002. Previously, she has worked in Manipal Institute of Technology, Manipal in the computer science department. Her research area are big data, artificial intelligence, IoT, web services, and network security. Today, she is going to take a session on big data analytics in the cloud. So, I would like to request, ma'am, to please start this session. I hope our participants enjoy your session and get good knowledge out of it. Thank you so much.
Okay. So thank you, Dr. Jugal, for your kind introduction. I'll just share my slides.
Yes, ma'am.
You're able to see the slides?
Yes, ma'am.
Okay, fine. Yeah, thank you. My talk is basically going to be on some work that my current PhD student has worked on. So she's actually worked on using Spark, and it was working with big data and worked with different applications. So one was visualization, security, and storage analytics, and looking at different parameters of these streaming platforms and certain applications also that were built using this. So whenever we're talking about big data, I mean, how do we define big data? So big data is going to be basically a combination. It started off being 3 V's, but now they've kind of introduced more of these V elements. So big data is generally going to be anything that could be dealing with huge volume of data. So that is something that we see generated in many of our applications. So if you're looking at Facebook, Instagram, because of the millions of people who are using these platforms, the volume with which the data is generated is definitely going to be very high. In addition, you have velocity. So data which is which has to be streamed constantly. So if in case we're looking at something like some satellite information that is coming, so this data would be coming continuously and maybe at a fixed pace. So all this information would have to be captured. Or if in case we're looking at our radar cameras which are there on the roads, so quickly they should be able to track when a vehicle is going to be passing. So velocity, you could have variety because you're looking at data which need not be only of a single format. You can have textual data, it could be videos, it could be images, it could be song files. So different variety of data. So you have veracity of data. Nowadays, they're even looking at visualization and the value that you have for data. So these are things that have constantly been added. So if we see volume is generally the largest thing. Nowadays, we look at terabytes, zettabytes of data. Velocity, for that, we generally have streaming data that is continuously processed. That is what Spark can deal with. Or it can be like Hadoop systems, which will work with huge batches of data. You can have variety of data like we discussed. It could be like generally when we say variety, if you're looking at say SQL data, so it is very structured. It has to be in a specific format. You can have a table which will have rows and columns and certain values of a certain format. So it can be int, it can be characters, it can be a date format or whatever. But nowadays we look data as very unstructured. So you can have data which need not follow a particular pattern. It can be some metadata followed by some data that is there. So because of this, there is going to be variety. So even if you're looking at say Facebook, you can have somebody who posts the video. Somebody could just be some image. Somebody could have just typed something. You have veracity because of the reliability of data. Visualization is something that we generally want because any form of information, if you want, if you just look at big volumes of say textual data, it becomes very difficult to understand any meaning from it. But instead, if we have different kinds of graphs, charts, it becomes easy to visualize the data. So generally, even I think many of us might be, even when we are marking students, if we have some form, maybe in the form of a histogram, we are quickly able to understand what is the highest marks, how many students have scored marks in a particular range. So it becomes easy. So you can have generally visualization tools are available which help us to visualize this data. And then finally, from all of this, we must be able to get some value out of data. Because even if in case you're looking at systems like say Facebook or Twitter, finally, what is the value that they're getting from all this? The huge volume of data that is there. Because nowadays they say like, data is going to be like the new oil that you see. So it has to be valuable. So finally, how do we get all this, the value from this huge volume of data? So if in case you're looking at any form of your big data analytics, this could be the flow of the information that would happen. You could have sources, so it could be in any form. It could be many times our IoT devices that we now have. Suppose you're looking at a big farm where they have a lot of, say, sensors, and these sensors will constantly be relaying information about the heat, the humidity, the temperature, and different parameters, maybe the sodium or the potassium level in the soil. So there's each thing generates data. Similarly, it could be healthcare data where you're looking at tracking somebody's health status, maybe somebody who's critically ill. His information is continuously stored and maintained. Similarly, you can have point of sales, so it could be in warehouses, applications like Amazon, where there is thousands of customers or millions of customers who are all placing orders. So any kind of analysis, you have web logs. So first thing, you have storage of data. So there should be efficient storage of this big data. So initially we see our older systems may not be able to scale up to this kind of huge volumes of data that are being generated. But nowadays, because we have storage facilities which are available, and in many cases you have applications like cloud, where like dedicated systems like say Amazon or Google, they're able to build huge say storage systems, so they can have big cloud applications where people can just keep dumping data. We definitely at a cost, but at least we have the facility of storing the data. So only storage of data may not really be enough. From the stored data, we should be able to do some form of processing. So when we're looking at processing because of the nature, like we just discussed, the value, the volume, the veracity, the velocity, because of all these different aspects, the traditional systems which were available may not really be able to scale up to process this form of data. Because in many cases, like if you're looking at Hadoop and all that, it becomes parallel processing. So you might have a master node, you can have slave nodes. So the main system will divide or to fragment data, send it to the different slave nodes, and slave nodes will do the processing. And finally, again, it is going to be sent in a compiled form back to the master node. So that is how these applications would work. Similarly, even with Spark, it's going to be very rare that you can have everything on a single system. So Spark also allows you to create multiple nodes and split your work such that all these nodes can divide and they can all share the burden. So we have these big data processing systems of applications which have been developed traditionally or have been developed only with the view of handling big data. So this is how things have progressed, because we had applications which were generating data. Because they were generating data, we had ability to store this data. Now once we have this storage that is available, some form we should be able to get the worth of this data. So this happens with the processing applications. And finally, like we saw, because again big data may not be sufficient to just have some calculation of values and storing it, but it would be make much more sense if we can have some graphical images, some pictures, some graphs, some bar charts, pie charts, which will actually show us interrelation between these different terms. So this is the big data analysis and visualization part. And from this, what is it that we get, or what applications can be done? So immense number of applications. So why there is so much of interest in this area is because there is a lot of revenue to be tapped. So if in case we see, like nowadays, many of us would have heard that Facebook is being sued in this country, Twitter is being sued in this country. Why? Because it is penetrated so deep into society that people at all levels are using it. So it could be somebody who's just using it for just for entertainment purpose, or it could be business enterprises which are using it to sell their product, advertise about certain products and things like that. So it has become a very powerful medium. That is why there is a lot of focus on this. So from this analysis and visualization, there can be different applications. One very important thing is targeted advertising. So this is something that all companies are doing. So many times we see that, okay, even if in case we are watching, say, Netflix or Amazon Prime, what happens over here is, depending on the kind of movies or shows that we are seeing, the Netflix will keep giving us recommendations. So they will tell us, maybe you can watch this, you can watch this. Why is it that they're doing it? Because they want people to continue using their platform. They want people to consume their data. So that is not that I get bored and then I exit or I leave Netflix. They want me to be a repeat customer. So with this, they're doing this kind of targeted advertising. So even if in case we're looking at, say, Amazon, so many times when we are shopping, it will automatically, you will have like no recommendations. People also bought this. You ordered, say, dal, they might tell you that with this type of dal, people have also ordered something else. So similar kind of targeted advertising. Similarly, you can have an application of big data which can be your fraud detection. So fraud detection, because you have huge volumes of data, to look for patterns in this data would become easy. Similarly, applications like weather prediction, because again, satellite images, understanding images become huge sizes of data. Similarly, you can have like, say, evidence-based medicine, prediction systems, recommendation systems. So these kind of applications which can all be developed using our big data analytics. So if in case we're looking at comparing this with our traditional applications, what are we saying over here? So in this case, one is because of, you definitely need high storage of data. So first thing, if we see, is going to be the data source. If you see, so in the traditional data source, it could have been like, from a simple system, a simple computer. It's not distributed, what data was generally obtained. But nowadays we see data can be obtained from multiple sources in different formats. It can be structured, semi-structured, it can be, like we saw, it can be streaming data, it can be static data, so different forms. So storage in the older systems where the size of data was small, smaller systems were enough. We had CPUs, maybe you have a local GPU, or you have, say, some terabyte of memory that we can create locally. Maybe you can push your data there. But today, storage requirement has become so high. So like we saw, zettabytes, terabytes. So generally now people have moved to maybe public cloud, private cloud, hybrid clouds. Database technology, our traditional systems had more structured data. So you could be working only with relational databases. But today, you're talking about unstructured data, because we have data in different formats. So that is why we have applications like NoSQL. That is not only SQL, it works with unstructured data. Data processing in the older traditional systems, it happened in a centralized manner. But in today's large volumes of data, you cannot work with a single processor. So generally, we have a very distributed architecture, and we will divide this data across multiple nodes, and all of them will be processing this data in parallel. Similarly, analytics, we could have smaller tools which could work with simple data, but now because of the scale and the dimensions of the data, we need further specialized analytical tools also. So these are some of the references that have been used for coming up with this presentation. So one of the applications that we are now looking at is a distributed machine learning. So machine learning and big data are very much closely tied together, because many times what happens is, because we have such huge volumes of data, to have these deep learning neural networks which will work with these big data becomes very kind of almost a natural, because only then you will be able to understand or get some important information or value or insight from the data. So generally, we do have a lot of machine learning applications which are now working. And because in many cases, the structure of these machine learning algorithms are also such that they use big volumes of data to kind of train them, test them, validate them. So what's happening is, nowadays the relationship between your machine learning and big data is kind of they're both very interdependent on each other. So in this case, we worked with static big data, and we have used Google Cloud. Okay, so there are many cloud service providers. So now you have Amazon Cloud, IBM has its own cloud services. Google is also available. Okay, so nowadays some of the common ones are, many people lean towards Amazon Web Services, but even Google is there, Microsoft is there. So all of them are cloud service providers. So in this we're actually working with static data. So like how we see Hadoop, which can be working, it's not data that is coming continuously. It is not streaming data, but static. So data which is already collected and then worked with. So in this case, we are working with a clustering algorithm. So in this case, so what does clustering do? It basically looks for similar kind of data and clubs it together. So here we were using the k-means cluster, and in this case, we were just kind of experimenting with a Spark cluster, which could actually work with big sizes of data. And here, just to see the performance, what we did is we kind of tweaked the architecture of our Spark cluster. So we used fewer clusters, we used different number of clusters, and saw how this particular algorithms performed. So if you see over here, we set up a Spark computational cluster in the clouds, and then we use the k-means clustering on big data sets. And then we analyze the performance on various classifications and validated the formation of optimal clusters using these two techniques. One was elbow method and second was the Silliert score. So the 4 data sets that we have actually worked on is going to be, one is a 3D row network, which had only 3 attributes and had 1 billion records. Similarly, there was another clustering data which had 4 attributes and 2 billion instances. It was only 25 GB. So if you're looking at terms of volume, we cannot really classify this as being very huge volume data. Another was going to be same form of data, but where you could cluster into 5 clusters. And then there was Hepta, which was just about 212 instances that was available. So using this, what we did is, we can see here, we used different number of nodes over here. So using the Spark cluster with the same data set, we worked with different sizes. So we can see when we had 5 clusters, 5 Spark clusters, there were 10 Spark clusters, 20 Spark clusters, etc., etc. So here you can see that when the number of clusters increased, so here in this case you can see the time taken was going to be more. But when you increased the number of clusters, like say yellow, or if you're looking at this, okay, orange, here in this case, the number of clusters, this was the number of clusters that you have. But you can see as the number of nodes increased, the performance that you have. Okay, so here in this case, this is the number of nodes along the x-axis. This is the time taken. You will see that as the number of nodes increased, the time taken drastically drops down in all these, okay, irrespective of how many clusters are formed. So this was one thing that we could see, that was data was naturally kind of parallelizable, and it could be divided across multiple clusters, and then the performance of these networks were seen to improve. So again, we have compared the correctness of these 2 models using these 2 techniques. One was our Silliert method, and secondly was the elbow. So again, with this, with the different data sets, we saw how the performance, like the number of clusters that we get, is it correctly matching with the other technique. So with this, we see this, and we see that the clustering could be done more or less accurately by using this many number of clusters. The second thing, so that was static data. The second thing that we are now looking at is streaming data. So the different kinds of big data analytics applications that can be developed with using our streaming big data applications. So in this case, like we've seen, you can have a user. So streaming data is continuous data that is going to be generated. And where is it generated from? Any of these applications that you can have. So it can be Facebook, Twitter, Netflix, it can be our IoT sensors, anything. Okay, so without stream processing, there's no big data and no Internet of Things. Okay, so especially with our Internet of Things, where we have sensors which are continuously relaying information, it becomes very important that you should have a system to actually capture this data, store it, and process it. Okay, so there are different algorithms and different techniques in which this can be done. So for Spark, when we're looking at you have specific ML applications where you can be working with this data. So again, in these kind of applications, social media trends, website statistics, intrusion detection software, and all these applications, we would require Spark streaming to be done. So Spark streaming, you can see what is the benefit of this. It is scalable. Same way like previously, you can divide it across large number of clusters. It is simple programming. In most of the cases, Spark could be using languages that say like Python and other languages, or Scala, okay, which becomes easy to program. So you can have different languages like Scala and all that is built specifically to work with your Spark. And generally we do it with a kind of your Unix environment where we give command line arguments. And then you can have both batch and interactive processing, and both Hadoop, Spark, and all of them, they're highly fault tolerant, because you can have a large number of nodes. At certain points, certain nodes could go down, but still your system would have to give you accurate results. So Spark is available from Apache platform, and Spark is open source. It is built on this concept of RDD, that is your resilient data sets, resilient distributed data sets, and that becomes the core of your Spark organization, your Spark architecture. That is where it works with your RDD. So that is going to be small batches in which it is going to be processing the data. Now, when you're looking at Apache platform, they have different things which are again available to handle your Spark platforms. So you can have Kafka is there is Flume, there is Zookeeper, there are so many different versions that are available for different applications that can be built. Similarly, like you can have things like querying your database. So for that, they have specific applications. So with respect to Spark streaming, we generally see you have a file system. So generally, this becomes your Hadoop distributed file system. You can have databases, you can have dashboards. So these are going to be the different applications that we have with respect to your Spark streaming. So when we look at Spark data that is coming in, data is coming in continuously. So what we do is you divide the data into certain batches of a specific size, and this is then going to be given to your Spark platform. So Spark streaming, and then processed data is also going to be available in batches. So Twitter, it has its own APIs, and with this API, if in case we need to use any of these applications, what we can do is Twitter, they have a streaming API. So we'll have to kind of install this API. You will have to register yourself. Each time you will have to be authenticated. And once you are authenticated, Twitter internally makes use of your OAuth to provide authorized access. So once you have access to this API, this will allow you to pick streams of data. So you can say you want to get information, say hashtag iPhone 13. So it will pick information or tweets wherever that iPhone 13 happens to be there. Messages that is only related to that. So that is going to be what happens with your streaming API. So in this case, you can see you can have your streaming big data analytics. And here we have worked with 3 different applications. One is a real-time health status prediction. Second is a tweet-based job search. Third is going to be for targeted sentiment analysis or advertising. So these are going to be different applications that were built using your Spark. So first thing that we have is a D-stream is a continuous stream of data, and it's called discretized stream or D-stream. So you have this input data. So you have a Spark streaming platform. It will divide the data into micro batches, and it is now going to be available over here. So again, the data works in terms of small windows. So in this particular case, what we're doing over here is we're working with these 2 particular data sets. So you have a heart disease data set, which is available in the UCI repository. And then we're working with a live tweet stream. So this UCI repository on health disease data set, it had about 14 different attributes and 303 data sets. So we have used this to train your model. So in this case, this can be your model that is going to be available. So what we do is you have a machine learning model, which we have trained using this heart disease data set. And with this, so you already have an application that is running in the background. Now, the next thing that we will be doing is you will be using streaming. So in this case, this is heart disease. So what would happen is a user, based on certain parameters. So maybe you can say that maybe you have a elderly parent at home. So if in case we have an application like this which has been developed, what happens is you will be required to feed in certain parameters in a certain order. So maybe you have to give your BP, your heart rate, your sugar, your different parameters which have to be fed into the system. So what will happen is, if in case a person has registered for this application of ours, what will happen is they will log in. They will then given all this their parameters, and these parameters are now going to be sent into our application, which will monitor, which will read in all these values. And using our machine learning application, it has looked for, or it has learned a certain parameters. So if in case maybe your heart rate is very high, maybe your sugar has also increased suddenly, so it will look for certain parameters. If in case it sees that there is certain area of concern, immediately what happens over here is you would have a notification which can be sent to the user, whoever has subscribed to this particular application. So direct messages, both the health status can be sent back to the user instantly. So this was one application that was developed. So in this case, you will see that all the parameters have to be fed in a particular order. And once these inputs are given in a specific order, the tweets are going to be captured. It will compare it with the machine learning algorithm that has been programmed, and it can send out an alert either to the patient or to the caretaker, or maybe to both of them. The second application that is developed is something which is going to be a tweet classification for effective job search. So here again, what we are saying is you'll be capturing tweets. So people might be searching. So hashtag search, and then they might either be searching for, maybe you have people searching for delivery jobs, people searching for IT jobs, for people related to nursing. So you have all this information that is available. So all this information is going to be fed in by using our Spark API. You will collect all this information that is available, and then some kind of analysis is going to be done on this data. You will classify them according to the job category, and then so based on this, so this is going to be basically an application that we have. So in this case, now we will be like an intermediary between job seeker and jobs providers. So we were capturing all this information, and now we have this information. So say you have some company which is now looking for drivers. So in this case, we have the information over here, and we can say, okay, these people were looking on Twitter for this kind of a job. So would you be interested in hiring them? So we can act as an intermediary and connect job seekers with job providers. So this was the basic application that we have over here. So here, information was collected over a period of time, and then we saw that some of the most common kind of categories that we saw. So a tweet would be given in this form. So you can see a cashier. This is a dental nurse. Okay, so this can be classified as healthcare. This is so for over a certain period of time, we captured all this information, and our Twitter API was done such that it could read this information and also form the classification. So it could correctly classify how many from each tweet, what category a particular person could come. So among the tests that we did, we saw that we had about 4691 job seekers, and in just 1 hour, when we had collected this information, it had classified all this 4691 minus 18. So 18 were misclassified. Apart from that, most of it was classified correctly. So the accuracy that our model obtained was about 99%. So we were kind of automating this process of collecting Twitter feeds and classifying it into what kind of a category. And once we have this big database available with us, we can kind of become a company. That is what many of the maybe recruitment agencies and people like that do. So we can be like an intermediary so that we could connect a job seeker with a job provider. The next application again that was built using Spark APIs was your real-time sentiment and then targeted advertising. So again, we were collecting feeds. So here in this case, you can see so you can have a user A. So you can have different people who are using this product. So first thing, we are collecting all these streams from Twitter streaming API. So all these tweets are collected, they are filtered, they are pre-processed. So in many cases, you'll be collecting information, but we need information only about, say, a certain product. So maybe you will say that a particular product, maybe Samsung has released a new phone or Apple has released a new product. So in such a case, we want to get the sentiment of the people. Are they happy with this product? Are they not happy? So what we are now doing is you're collecting this, you're doing a sentiment analysis. So this is by using some form of NLP. What we did over here is we were just dividing the words. We were getting it like a bag of words, and we were counting the number of positive sentiment words, number of negative sentiment, number of neutral sentiment, and whichever was higher, the entire message was classified to be of that type, so positive or negative or whatever. So in this case, we had this information. So now if in case the user gives a positive feed, we have that person's Twitter ID. So he could be advertised similar kind of products or something from the same company, etc. If in case it is a negative feed, maybe you can have some kind of, the company can be informed that out of 4,000 tweets that we've collected today, there were 2,500 which had a negative feedback. So in this case, the company can do some kind of targeted advertising, or they can reach out individually to the customers to find out about what exactly was their pain point, what were they not happy about, and the company can rectify and move forward. So this was the algorithm that was used for this. So you were classifying a particular feed or a Twitter message into positive, neutral, or negative. So in this case, you can see a tweet like my iPad works fine. Okay, this is a positive. Similarly, this is good, but picture quality is poor. So in this case, we can identify. Similarly, you have some words which will say that this product is negative. Okay, so it was a failure. It is a disappointment. So some words like this, if we have, we can classify it to be negative, and then we can have some targeted message. So if it is a positive, you can give a positive message. You can say we have new promotions, we have new items. So if it is neutral, again, you can do it that way. If it is negative, you can call them on a toll-free number. You're giving them some way in which they can reach out to you, or you may even be able to get in touch with them. The next thing that we have over here is an optimization model for Spark-based predictive analytics application. So in this case, what we did is we kind of optimized the Spark platform. So in this case, what we are saying over here is this is the model that is developed. So you have a machine learning pipeline. We do some kind of fine tuning over here, and then we have an optimized model that is obtained. So we'll just see what exactly this is meant by this. So here in this case, what we're saying is you have a big data set that is available. So we have worked with these 4 data sets. So you can see you have the Higgs data set, which had about 28 attributes, and it had about 7 billion records. The Suzy data set, which had about 18 attributes and 5 million data, diabetic and heart. So this was the different types of data sets that we worked with. So you were feeding in the data set over here, and here in this case we were using a kind of a ensemble. So we were using different data models that you had over here. So logistic regression, decision tree, random forest, support vector machine, etc. So all these were used to work with this particular data, and then you were seeing the classification of this. So for each of this stage, what we were doing is, once we got this for this entire model, we were then fine-tuning the hyperparameters. So we were seeing that for a particular data set, which of these mechanisms is working well. You want to do clustering. So in this case, maybe you can be looking at using a particular form of data. If in case it is, you want something which is more explainable, maybe a decision tree can be used. So depending upon this, we've constructed like an ensemble from the data set that is given. We found out which could be the best model. We did a little bit of tuning. So hyperparameters that are available in each of these ML models were little fine tuned to see that how the performance could be improved. And then the best model was selected, and then we were using it for our machine learning application. So in this case, you can see with the Higgs data set, we can see that this was what was obtained. So with logistic regression, we can see the F1 score and accuracy. Same thing with your decision tree and different parameters. So we can see with the Higgs data set for your classification, we see that your decision tree performed best. Similarly, on the SUSY data set, your multi-layer perceptrons performance was better than everything else. The heart disease, a simple model like your logistic regression. Similarly, diabetic retinopathy, this was seen to be good. So we can see that for smaller data sets, for simpler data sets, simpler models like logistic regression work better. But for the bigger data sets, maybe a better machine learning algorithm would be better. So in this case, again, we worked with this with using different number of nodes. So we tried so this was where we played around with the hyperparameters. So in this case, you can see that we had execution time if it was a decision tree based on your Higgs data set. This was in terms of the different hyperparameters and information that we were collecting. This was the amount of local and remote blocks that was fetched. So this was because if you're looking at these, there is a lot of those internal operations that would happen. That is your worker nodes and the main, the slave nodes and the main node. The data is going to be transferred, how many calculations are done. So all this is calculated. So again, we tested it with different configurations. We tested it with 8 CPUs, with 4 virtual CPUs, with 2 virtual CPUs, etc. So with each one of this, we saw how many, and we used different number of workers and slave nodes, and then compared the performance. So this was something that was done in order to increase the number of the parallelism that you have. So these were some of the Spark hyperparameters that we kind of tuned. So you can have the number of cores, the number of tasks per CPU, memory fraction, storage fraction, etc., etc. Okay, so these were some of the hyperparameters. So these are like some of these hyperparameters. So you can see over here, spark.cryo.unsafe. So this can take a Boolean value, which can be true or false. So these were the different execution times of these different models. The next thing that we will see is going to be the visual analytics on big data. So in this case, so like we said, visualization is also something very important with big data. So when we're looking at visualization, there are many software tools which are available. Commonly used tools are something like Tableau, because Tableau is it is a paid software. That can be a disadvantage, but otherwise it is very user friendly. It gives you lots of different ways in which data can be represented in a nice and presentable and easy to understand manner. So in this case, another visualization tool that we worked with is d3.js. This is a free software, but it may not really have as many features as a tool like Tableau. So here the data set again that we have worked with is the Chicago crime data set, which had about 23 attributes and about 7.8 million instances. So here we can see that we did different visualizations in the status of the crime. So during which months the crime happens, what are the locations, what are the types of crimes, different actions that were taken for each of these crimes. So with respect to Tableau, we were able to generate different kinds of charts and all that. So Tableau is well suited for quick and easy visualization, and it is commonly used for making charts. Similarly, we had worked with the d3.js. This is suited for extraordinary charting requirements and high interactivity. So we saw that very interactive information, like when you're working, say, in an organization which is taking care of crime control. So in such cases, what will happen is something that is a very active or interactive software tool becomes easier to work with. But again, it is more difficult to actually code and to write it when it is in D3.js. Another application that we worked was a geo visualization platform. So in this case, we worked with a tool that was your ArcGIS. So this has a single page, it was a single page application. It was running on Node.js in the backend. MongoDB was used for storage of the big data. And then to get all the visualization features, different tools like Knockout, Leaflet, Mapbox, etc. was used to create your visualization. So here you can see you have a front end which had all this information, and the back end which could have your the functionality, your data access layers, and etc. So these were interactive maps which were used for showing the Dubai, Abu Dhabi roadways and waterways that are available. Another application that we worked with was privacy and security. So like we know, big data has multiple challenges in terms of security. One, because of the first thing, because we generally store it in a distributed environment. So when you are actually dividing the data, sending it to the different nodes, there is a proper probability of breach of data happening over here. So rather than it being at one point, then because of the distributed nature, at multiple points there could be breaches that could happen. So this is one downfall. Second thing that we have is because in many cases we're saying that the data is going to be stored externally on a cloud somewhere. So in many cases the data is not even in our control; it is with somebody else. So we don't really know what that person will do with the data. So in many such cases, what happens is when we're working with big data, that concept of security and encryption of data would definitely seep in. So here in this case, we can see in this particular application, what we have worked on is that we have a big data file. So we have worked with MPI over here. So MPI is again another distributed platform which allows you to actually manually. So MPI is kind of it's closer to the hardware level. So you can physically give commands if you want to create how many nodes. So here again, you can see that there is one master node and there is multiple slave nodes. So, and you can actually set the communication. So MPI can happen over a distributed environment. So here in this case, what we have done over here is you have a big file. So we have created n number of nodes. And when a user wants to send data across this MPI, what he can be specifying is he can specify how many nodes he wants to distribute this data over. So this becomes random. So for a person to break the code becomes difficult. So what happens over here, he can specify how many chunks he wants to break that data into and store it separately. So that is the manual part that would happen over here. So in this case, we make use of the AES CTR algorithm. So AES algorithm was used, and we're using the counter method to file in parallel. Now each of these encrypted files is stored in a random manner in any of these nodes. So this is nothing but a simulation of a cloud environment that you can have. So at different nodes, you are going to be storing this information. And then the number of parts n and the encrypted part location is a secret. The system provides security. And MPI works very closely with the hardware. Hence, performance can be maximized. So like how we have C, which works more with closer level to the computer. C is faster when compared to languages like Python or Java, which have a more layer of they're not really working with at the level in terms of the memory location and things like that. So MPI also forms the same thing. It works more closely with the architecture of your language. So you can have a file over here, and what we would be saying in this case is a file which is available. We would be using the CTR method, the counter method, and the AES technique for encrypting a file. And then this file is now going to be sent. It is stored in a random location in your network. When this file has to be decrypted, again, that you'll be using the decryption key, decrypt the message, and then the file can be sent back to the master node. So again, for this, we again counted the number of the performance of your system by using different number of nodes, different number of processes. So we did different kinds of calculations over here and saw how much of time is required both for the encryption process as well as for the decryption process. So how much of a time was being transferred in, was taken up in the during the transfer, how was the encryption, how was the decryption, etc. happening. So again, with decryption also, we could see that the results were more or less the same as that of encryption. So these were the different applications that we have seen with respect to your big data applications. Now, since this conference deals with security also, maybe I just thought that we will briefly see another presentation which is on with respect to security, and it could be with respect to big data security, and moreover, due to this pandemic, what are going to be some of the major challenges that were faced by many of the organizations. So if in case we look at security, these are certain aspects that you could have. Ransomware, you can have a system which is hacked, you can have phishing attacks. So these are different worrying or areas of concern that we have whenever you're talking about secure data. So especially in your big data applications where the volume of data is more, in many cases it can be sensitive information, in many cases it can be information belonging to somebody else. Maybe a hospital is sending all its information and you're putting it up on Google Cloud. So it becomes the responsibility of Google to ensure that this data is secure. So for such kind of applications, what are different measures that can be taken? So phishing attacks is also something that is very common. Phishing can be something which is like fake. So your website can be made which looks exactly maybe like your banking, like your bank's application. Suppose you're using ICICI Bank. Everything might look the same. But maybe when you look at the website www.icici.com, maybe their site, there will be some phishing site which will come up. It will just be the same. It will be www.icicibank.com. So some small change. A person may not really identify this also. So there could be different types of cyber attacks that we can have. One can be malicious domain. So many times there can be people with a malicious intent. So somebody wants to capture your maybe your credit card number. Okay, somebody wants to capture a password that you are entering somewhere. So these become people who are malicious. They want to do something with a bad intent. You can have malware. Malware, as the name indicates, is going to be malicious software. So many times there can be some software that you have installed. You have to say open an Adobe file. You don't have Adobe with you, so you will install it. But maybe it is from a malicious website and they have given you some malware. So what would happen when you download the software? The malicious software that is also installed along with it may run in the background, and it might do some malicious things. It might destroy some of your files. It may make copies of your files and send it to somebody. So these become very challenging things, especially if you're working, say, in a financial sector where the things, very critical information is available with you. So if in case you have such kind of software which is stealing the information, it is really going to be a matter of concern. Another kind of cyber attack that we see very commonly is ransomware. Nowadays, it is quite common that you can have this ransomware. Sometimes we've even heard, like I think sometime back, maybe sometime last year, some big company in the US, I think some energy company in the US, they were attacked with ransomware. So their whole system shut. They could not generate any electricity. And this was, I think, in the middle of winter where it was very, very cold. But this company just could not generate energy, and it was actually providing energy to the entire district. So in such kind of problems, many times we see that these kind of attacks will not be just for a particular system, but very essential services also. So in such case, we can see that you have what is called a ransomware. So what happens in ransomware? Maybe you've downloaded a software, and this will hold, it will freeze everything that we have. So it will be like it'll ask for a ransom. So maybe if in case you transfer this much or you transfer so many Bitcoins, so many of these transactions happen in your digital currency or your blockchains, your Bitcoins, Ethereum, and these platforms. So if in case it requests the user that you have to deposit, say, 4 Bitcoins in my wallet, only then will I be able to allow you to access your system. So these are ransomware. We are not really sure whether you pay the amount or the ransom and they will spare your system or they will restore it. Because anyway, all this is digital content. They would have already made a copy of all your data. We never know. And we cannot be sure. Maybe he's unlocking today. Tomorrow again, he might come up with a new threat. So these are always certain problems that we have when we're looking at this. So when we're looking at cybercrime during COVID, okay, why exactly this happened? So you can see that because people were doing more and more activities online. So activities just to maintain social distancing. You did not want to go out to shop because the shops are crowded. You were doing online shopping. Everybody, I mean, we are all used to communicating. You're not traveling to the office. You have to complete your work. It used to be through online meetings. Okay, so information was being shared very commonly. So this became a kind of a point for a lot of these malicious people to actually breach many networks and take advantage. So there were many vulnerabilities that were seen, and many times it becomes because of our nature. Okay, so in this case, so some of these applications that we see, like we passwords, we might keep very common passwords. We might keep passwords like our name or our parents' name or our child's name. So such things become very easy for people to detect. So some of the problems that we're seeing was phishing was happening quite rampantly because a lot of websites came up. So many of these websites we were not able to authenticate. Ransomware was detected in multiple places. Critical infrastructure, like I was telling you, nowadays security is no longer only tied to very specific things. It is things which people could use. Your hospital, your company, your telephone company, your electricity providing company, whatever. So it was targeting even organizations like the World Health Organization. You had a lot of fraud schemes which were coming up. So I think even in India we have heard about that. In Hyderabad and all that, there were a lot of these schemes where people were giving money to people at some interest rate, and then they were coming and claiming and harassing the people to pay that amount. So there were so many suicide cases also which happened because of that. So similarly, a lot of fake news was being distributed. Lot of all these kind of related to COVID itself, lot of fake news and all that was being spread. So these were some of the major issues that were seen with respect to crime. So in this case, what are the things that some of the things that we can do? And so many of these apps were compromised. So Zoom, many of you all would know, like because maybe schools, colleges, everybody, companies started using Zoom. So many times we would have Zoom bombing. Somebody who's uninvited would suddenly be in that meeting. They would present something which would embarrass everybody. So a lot of these things were happening. Similarly, you could have applications like Netflix, TikTok, all of them were hacked. So Netflix might have credit card details of so many thousands of people. So if they hack these networks, they can take away information of so many people. This becomes very concerning issues. So you have Zoom, which was bombed. So many problems were there with Zoom. Okay, but Zoom again, they also learned because within very short period of time they came up with solutions. When suddenly the pandemic started, Zoom was a small company, but because suddenly this thing came up, they suddenly scaled up. But when they scaled up, there were many issues that they did not consider about security. So when people started using, they were able to detect more and more of these flaws. And then Zoom, because it was a very innovative company, they were also able to come up with solutions for these kind of problems. So certain security issues provided by Zoom, they had passwords, they had virtual meeting rooms. So many times you would have a meeting room. If somebody had to enter it, he needed permission. Somebody in the meeting could only allow him to enter. So this way, a lot of people, you couldn't just bomb into these Zoom meetings. So you had to be, so these were certain issues that you have. Similarly, you have Zoom Premium also, which is available, where they give more security features to their users. So many organizations, companies, all of them moved to Zoom Premium. So similarly, apps like we discussed, TikTok, Twitter. Okay, these some of them have been hacked, and a lot of their information has been stolen. Same thing with Netflix and these phishing sites also. So people would have created applications like web pages which look very much like the original Netflix. So So you go to that site, maybe it'll either steal your credit card information or it'll redirect you and take you to some other malicious sites. WHO's website was hacked. Not their website, in fact, their systems were hacked. Okay, vaccine makers, a lot of these vaccine making companies have also complained that their systems were hacked. Okay, Twitter accounts of some popular people was also hacked. So these were certain, not a lot of issues that was seen. So if in case we have these issues, what is it that we can do? So cyber crimes in the UAE, because that is where I currently am. So these were some of the issues that we're seeing. There were a lot of fake medicines being sold, employees' information being stolen, phishing increased by about 600%. Okay, so we can see these could be different applications or the different issues that we have. So, what are we doing to combat these problems? So, some of these problems can be combated because again, big data will come into the picture. So many people using these systems, so much of volume of data generated. So, if we can get some value out of this data, because that is what we finally want. If you are able to use good machine learning algorithms, study patterns in this data, and then come up with recommendations for people, it will definitely improve things. Similarly, here you can even have things like now, because normal computing on big data is becoming difficult, people are now looking at quantum computing. Okay, so quantum computing is an area again where a lot of things from quantum mechanics, physics, where they're looking at how things can happen in different dimensions. So this has really improved the speed at which things can happen. So when you have big volumes of data, you have good machine learning algorithms. It will also become extremely efficient if we have good quantum computing systems which can do all this fraction of a time. So certain tips that nowadays many of us are quite aware of. So one thing, like how we keep saying maintain social distancing, keeps isolating yourself, keep a distance. Okay, the same things will apply over here. Practice social distancing. Okay, don't disclose passwords and all that to unknown people. Use protective equipment like antivirus, your firewalls. These would be very, very important. Okay, avoid contact. So don't open unknown mails, suspicious looking mails. Clean your systems, your mobile phones. Remove applications which are not used very frequently. And finally, don't leave any footprint as far as possible. Keep removing all your digital footprint also. So these are some of the commonly used things. Keep updating your software, use strong passwords, avoid opening anything that you have any kind of a doubt that it is from a malicious or suspicious person. Don't open such mail. Okay, check your privacy settings in all your applications that you are using. Many times they will say you are permitted to use your camera, your mic, your speaker, then even maybe your folders, your files. So we should read all these privacy agreements carefully. Okay, strengthen your home network. So have good firewalls and things like this. Take backup copies always. Right. So these are some of the checklists that we have whenever we're talking about cybercrime. So with this, I think I would end with my presentation. If anybody has any questions or any queries, I would be more than happy to take it. Any questions?